So today we're looking at how to derive vertex formula and quadratic formula. So when we're studying quadratic functions, there are two forms. One is writing as this. And another form is write as a x minus h squared plus k. Now, this form is called standard, and this is called vertex. Now, so standard form, vertex form. The reason we call that vertex form is, for this one is obvious, because this gives us the vertex point. The vertex point will be h and k. So when x is equal to h, you can think of that. When x is equal to h, then x minus h is equal to h minus h equal to 0. So therefore, on here, this term is 0. Then y would equal to k. Okay, so when x equal to this, then y equal to k. So that means that point is our vertex point. And from that point on, if a is positive, then any number which is not h will be bigger than 0. So therefore, whatever, as long as if h is not equal to, x is not equal to h, then y will be bigger than k. So that means you can just see this kind of scenario. This is our vertex, which is h comma k. That's when a is greater than 0. What happens if a is less than 0? If a is less than 0, let's put down here is a greater than 0. A is positive, you got a smiley face. What happens here, then we know this term is, if x is not equal to h, this term square will be greater than 0. But a is negative, so a, x minus h squared, will be less than 0. So therefore, y will be always less than k. Okay, so that means in this case, our graph is looking like that. Okay, now I call this front face. So a negative, you got front face, a positive, you got positive face. And you can understand why it's so by just looking at this form, this the vertex form. Okay, so now we are going to derive the vertex formula. So when we study quadratic functions, we have two forms, standard form and vertex form. We have two formulas. One is called vertex formula. That's allow you to find the vertex point, which is h equal to minus b over 2a, and k is 4ac minus b squared over 4a. And then we have the famous quadratic form formula. So that is x1 or 2 that equal to minus b plus minus b squared minus 4ac over 2a. Well, I'm not really good at memorizing things. So for me, everything has to make sense. But the reason I can memorize this is really because I know how to derive it. Once you go through that process, it make easy for you to remember this two formula. Okay, so now we're going to looking at, so I'm going to write this on a bit of late, put on this side. So it kind of remind us what we're trying to get. So h is minus b over 2a, k is 4ac minus b squared over 4a. Then xn1, 2 is minus b plus minus b squared minus 4ac over 2a. Okay. Okay, now we're going to do that. All right. We know these two forms. They're just different way to express the same function. So therefore, we know ax squared plus bx plus c would equal to a x minus h squared plus k. All right. So we're going to expand this. So x minus h squared is x minus h times x minus h. Now, to expand that, we use FOIL. So x times x times h. So we got x squared minus xh, then that multiply, which is minus hx, and that multiply that, both negatives, so the h squared. So that equal to x squared minus 2hx, because xh and hx is the same thing, same value, equal to that. Now, this actually is from this identity, that 2ab minus b squared. Now, when I was learning algebra, we are required to memorize things like that. But if you don't, you can always work that out. But definitely helps you if you memorize this, make things a lot faster. And it's not that hard to memorize it. Once you go through like this process, you'll understand why. Okay, so we have that. Then we can basically plug into this equation. So it's a x squared minus 2hx plus h squared plus k. Okay, we're going to erase that. And we're going to put everything together. The a got distributed. So ax squared minus 2ahx plus ah squared plus k. All right, now we can see we got this term, ax squared both sides. So we can eliminate by minus exactly the same thing on both sides. So remember, we're doing algebra. So the essence of algebra is that if you do operation on one side, you have to do exactly on the other side of the equation, and then the equation is still true. So now we ends up with this, bx plus c equal to minus 2ahx plus k. And this is true no matter what the value of x. X could be any value, and this equation is true. And because of that, we can just find the value that works for us. So for example, we can say, what happens if x to 0? Well, if x is 0, on the left is c, on the right is k. We're missing something here. Sorry. We still have a h squared plus k. So we got on the other side, on the right-hand side, this part is 0 because x is 0. So we got a h squared plus k. Very good equation we have. Well, we still don't know, we still have like how many variables? We got c, a, h, and k. So there's the way to go. Okay, but at least we'll find one. Now, which means if we can get rid c on this side by taking it out, let me remove this to put this side so we can use that later. Okay, so that means we can take over that. Now, we know that c now has to equal to ah squared plus k. That means if we minus c on this side and then minus c on this side, then that both uh, uh, are canceled. So now we got bx equal to negative 2a hx. We got x on both sides. Well, since x could be anything, well, we just set x to 1. So therefore, we got b equals to negative 2ah, which is the same thing as, say, 2ah equal to b. Then we minus negative 2a on both sides. Then our h then is equal to b over 2a. So because this is positive, negative is negative. Positive divided negative, negative. So we got that h. Very important now. We got h. Once we got h, we can get k. So now we got h equals to minus b over 2a. Now we can just use the equation we established earlier on, which is c equal to ah squared plus k. And what we got here now from here. So we can, since we're going to find k, basically we're trying to find, derive this formula. We derived this formula already. We're trying to get a second one. So that means k has to be equal to c minus ah squared. And we know what h is, which is minus b over 2a, that squared, equal to c minus a. Then negative b squared is just b squared. We have that. Then 2a squared is 4a squared. Then we can cancel by 1a. Then we got c minus b squared over 4a. That's where that's the 4a come from, because that. And we can rewrite c as 4ac over 4a and minus b squared over 4a. So now we have the same denominator, so we can add them. It's 4ac minus b squared. Now we find our k. So now we've got our vertex formula. Now we just need to find our quadratic formula. That turns out actually to be pretty easy if we use the vertex form. And also, since we know we have the vertex formula now, and we can write our formula in terms ABC. Okay, we're going to use y equal to a x minus h squared plus k. And remember, when we're looking for this, is basically looking for the x-intercept. So at x-intercept, y is 0, and that's basically what x-intercept is. So if you look like that, this is axis. On the x-axis, y is always 0. So there's 1, there's a 2. Okay, so therefore we rewrite this as 0 equal to a x minus h squared plus k. Now here could be people got confused because this x is different from that x. Now as a function, x can be anything from negative infinity to positive infinity. So that's what we call its domain. Okay, but this one is saying there's x-intercept, so the x1 and x2. So this x is basically only represent x1 or x2, and not the same as the function. On the function, x can be any value, but on this equation now, x actually is fixed, which is something we call unknown. We just don't know that yet. We need to find out. But this x is fixed versus this fixed can be any value. So sometimes the context is very important. This is part of the algebra. Algebra will use letters, but what do they mean is really to do with the context. So basically, from here to here, we shift the context. Here is a function, and here is say what happens at the x-intercept point. So we know at that point y is 0, so therefore we got this. Then we can write as a x minus h squared plus k equal to 0. So therefore a x minus h squared plus equal to negative k, then x minus h squared, we divide a on both sides. We got minus k over a. And then x minus h, we're going to square root on both sides. We got that. But when we do square root on both sides, we got to be careful. For example, if if let's do something. If m square is 4, then m can be 2 or negative 2. When you do the square root on both sides, the variable actually could have just two different, basically opposite numbers. It's come down to really is negative square is also positive. Positive square is also positive. So that is because of this. So therefore, we write as plus minus. It just means we have two. One is plus, one is minus. Now we got that. Then we're going to add h on both sides. And we got x is equal to h plus minus negative k and a. Now, if this is given, the vertex formula, then we can just use that formula. But a lot of times they give us this standard form. So that means we have to basically rewrite this formula in terms A, B, and C. But anyway, that's where we got start. This is a good step now. So now we're going to using our vertex formula to get A, B, and C. So now we have, I got X. What is our H? H we know is minus B over 2A. So we got that here. And plus minus. And this is K is 4AC minus B squared over 4A, then divide by A. So this is called, I think it's called complex fraction. It looks scary, but actually it's not that hard. You have to realize sometimes this fact, A divided by 4, we can write as A times 1 over 4. So anything divide number by, we can rewrite as a number multiply its reciprocal. Same thing we do with this. Okay. I'm going to work on the side just to show you that. Minus 4AC minus B plus B squared. This actually is minus, we need to go back. Minus 4AC minus B squared over 4A and divide by A. Now, before we do the divide by A, we're going to change the top, make that into a positive. So we want to get rid of this. Okay. So that means we're going to use this one, distribute to this. You can think negative as -1 times everything. So we actually got B squared minus 4AC over 4A and divide by A. Then we change that to B squared minus 4AC over 4A times the reciprocal of that is 1 over A. So we got b squared minus 4ac over 4a squared. Okay, so remember how that's how we got there. So we can rewrite this equation now become negative b over 2a plus minus b squared minus 4ac over 4a squared. And now you can see the formula b squared minus 4ac. Okay, with that, then we can do something here. We can rewrite as negative b over 2a plus minus on the top b squared over 4ac over bottom is 4a squared. Now, what's the square root of 4a squared? And we can rewrite this 4a squared as square root of 4 times square root of a squared. Now, square root of 4 is 2. The tricky part is this. It depends what is positive and negative, because this is always positive, square root of a squared. But if a is negative, say it's negative, or I mean, let's say positive, let me say 2. If a is positive 2, and that's pretty easy. It's just square root of 4, and then square root of 4 is just 2, so that becomes 2a. So a is greater than 0. It's come down to is a is less than 0, but a squared is always positive, so square root is positive. But if you just write it like 2a, because a is negative, then this becomes negative, and that's not the case. This one is always positive. So we have to rewrite it. If a is less than 0, or that equal to negative 2a. So that's the part of that. But notice we have plus minus already. So we're going to say 1 plus 1 minus. If this is a plus, plus times negative, positive and negative, negative, this is negative times negative, positive. So, and for that reason, we really just say, okay, this whole thing just equal to 2a. Because if it's negative, we have negative here, positive, positive, so no problem. Now we're going to combine this. Since we have the same denominator, it becomes negative b plus minus b squared minus 4ac. Then we have it. Now we prove the quadratic formula. So as long as you know the two forms of a quadratic function and you know how to derive the two formulas, then you have a very good mastery of the quadratic functions. All right, I will see you next time.